So the exam, the more I'm doing it, the more I'm looking towards like doing like five, either like five sections of worth like 20 points a piece, and with very clear rubrics for each of them, so that it's very easy to get half credit on each of them. I mean, again, I'm gonna do the best I can. If I have to curve it, I have to curve it based on the format. But it's we'll see how it goes. Um, we'll see how that goes. Yeah, and as far as summer one and summer two, the registration is April 2nd. So yeah. Um, Next on the agenda, also you do have homework. So I also want to take the chance to go over the homework because that's going to be extremely useful for doing the homework is going to be extremely useful for the exam. So hopefully you've had the chance to go through the homework, but if not, I'm going to go ahead and pull it up and talk to you about the pig assignment, which I really like. It's honestly one of the best ones I've given out for this class. When does that due? April 6th. So far. If people need more time, just email me after the exam and tell me you guys need more times, and I'll probably extend the due date. So, The exam is a week from today, so let me go ahead and make a formal announcement. Yeah, let me go ahead and just post an announcement. Boo, boo, boo. CIS 1051 exam 2. The second exam will be on April 2nd. Yeah. April 2nd. It will be during the normal class time. So let me just give you a big quick thing about the hurricane tracker. If you're running it and nothing is showing up, like, you get the Atlantic Basin, but it doesn't look like anything's ever going across it. The most common thing, and I think I put this in there, is you want to check your longitude and latitude. Specifically, longitude and latitude aren't necessarily X and Y. You want to double check which one refers to vertical steps and which one refers to horizontal steps. So check and see if maybe you need to switch them around, because because they may not map cleanly to X and Y. Yep, I will keep. So yes, I will answer pig stuff in a second. So let me just finish writing this. It will be during the normal class time. It will be on Canvas and proctored over Zoom. Is open everything except for consulting with another live human being. Please have a webcam. If you cannot make the normal class time, please let me know. Okay. Yeah. So, okay. Yeah, that's why. So, again, hurricane tracker. Common thing about that is, so a couple common things. If you're not working in idle, then you need to put in turtle.done at the end if you don't want it to. Yeah, you can put yourself on mute during the exam. you got to put in turtle.done at the end, and that will stop it from just disappearing at the end, although that's not too bad, like if you see it go across and boom. If it looks like your computer's, shows up a map of the Atlantic Basin and you're not getting anything, try switching up your longitude and latitude. Look up what longitude and latitude really are. Another common question is, how do I know what wind speed is? What wind speed corresponds to what category? And the answer is, look it up on Wikipedia or on like some other, scientific resource. I don't know what they are off the top of my head, but you can pretty much just look at that and look that up pretty quickly. And then figure out what wind speed applies there. The hurricane assignment is a heck of a lot easier than it actually looks. So it looks way harder than it is. So don't let it intimidate you too much. When in doubt, print stuff out to make sure that stuff is happening. Okay. So with regards to the pig assignment, let me go ahead and open that up on here so that I can go over it. Yeah. Okay, share screen. Hopefully nothing's too embarrassing on my screen. So let's see. Okay. So we've got pig, which is another nifty assignment. Rules of pigs are as follow. And then it's basically an assignment that builds up on itself. So the idea here is that you're not going to be necessarily it's less about turning in like 9 separate exercises and more, or 8 separate exercises, and more about taking what you did in the previous exercise and then building on it. Okay. So the idea here is that pig, works like this. You take a single 6-sided die and roll it. You've got 2 choices of turn. You can either roll, in which case on a 1 you don't get anything for the turn and it becomes the opponent's turn, or in 2 and a 6 you get that number and add it to your current score. Each time after you roll, if you didn't roll a 1, you can decide to hold, where you bank your points for the turn. The first person to reach 100 points wins. So, the first thing you want to do is basically do this. Is to basically simulate just a single turn, and where a player rolls until a 1 is rolled, or the turn is total is greater than or equal to 20. So this is a good strategy that the computer will be using, which is basically the computer will try to get at least 20 points each turn. So, right, it will roll until it hits 20, or until it gets a 1. For held at 20 outcomes, what you're going to do is that you're going to simulate like 10,000 of these or something. Or here they did 100,000, and you output your results of those and what are the probabilities. So we can see here that basically that with the hold or 20 strategy, that we estimate there's a probability of getting a 62% chance of rolling a 1 before you hit 20 points. And then these are the various results you could get. Because you could have now why does it go all the way up to 25? Because you could roll a 21, because you could have a 19, go, that's not 20, I'm trying to get to 20 or above, roll a die, it comes up 6, so you got 25 points for the turn, and then you bank it. 3 just changes that, where you change that so that the user specifies what value they want the computer to stop at. In other words, like, maybe I don't want to try holding at 20. That's that seems too risky, 62% chance of hitting 0. What if instead I do a hold at 15 or a hold at 12 strategy? What is the outcome of that? And then I also want you to figure out what the probability is of reaching 100 in a single turn. And then, given a player score, simulate a single turn of pig where the player rolls until a 1 is rolled, or until they get a 20, or the score is basically greater than or equal to 100. So basically here you're kind of combining where the end condition might be that they've won, and then we use that to build a game. And then we can simulate like how many turns does it take you to win using the hold at 20 turn. Then we've got 2-player pig, where basically each player where a player rolls a 1. And then this is interactive. So here you've got 2 automated players playing against each other. Here it's interactive. Right? You can see with the output there that it's interactive. So there are optimal strategies for playing Pig, because the guy who wrote this assignment is a huge nerd about that game and basically did like crazy numerical analysis about it. But the idea here is that this is Monte Carlo stuff and random, which sounds great for the exam, because if you've looked at the practice exam, which I went ahead and did you a favor and gave you like 35 points from the previous exam and put it on the practice exam from last semester. So that forces me to come up with some new questions. All right. Oh, yeah, that's what I thought about doing today. Yeah. All right. So Hal's moving castles about. So just basically figure, some description things over here. This was from last year, the whole file reading thing I showed you. This one is read a file of numbers. I don't know why I made them both extra practice. Oh, no. Yeah, this is 20 points. This one is extra practice, adding up a whole bunch of numbers. Specifically, taking this file and adding up all the even numbers you see in it. Then figuring out some methods. There's going to be way less questions on the actual exam, but I wanted to give you as many practice problems as I could. As many good practice problems. Things that I think extra practice either means that it's exceptionally hard or beyond the scope of the exam, or you wouldn't get that many points on it. For instance, for the method problems, those are I make the ones that are worth 0 points. They're the ones that I find extra difficult. Hey, Laser. So this one's a common problem. Given a string, write a function that returns the most common letter in the string. So that's a whole lot like the word count problem we did. And then here's the practice problem from last year, which is very amusing. Expect to get here's what I can tell you will be about the Monte Carlo problem. I am going to give you a problem. I'm going to posit a game to you, but the game is a scam, and you've got to use some statistical analysis to prove to me that it's a scam, essentially. So, I'm going to say, the chances of you winning this game are 50-50, but I want you to actually to calculate what the actual odds of the game are, because they're going to be way worse than what you think they are. Because I really like scams. They're really interesting to me. I don't like pulling them on other people, despite this problem. So, in fact, I might grab one today and do a Monte Carlo analysis on that. So, the two things I really want to go over are file reading and Monte Carlo analysis. And so basically there's 3 things: lists and list operations. Well, list and string operations specifically. File reading, which gets into the whole string manipulation, and then Monte Carlo simulations. So, yes, let's see chat. Number 6, so let's see, we've got some in the Pig Lab. For the last game where the computer plays against a computer, the user has total control. The user has total control for the in the final interactive Pig game. So he can decide to try to go for broke. Right? The user doesn't have to try to get 20 points. Can I explain number 6? Do you mean number 6 on the exam? Number 6 on the exam. So this fella over here. So I have a coin that's slightly weighted in favor of heads. It will land on head 55% of the time. How would you simulate this? Yes, it is being recorded. So, so here what you would want to do is use the random function and basically have an if-else. Basically, I would use the random function, simulate something between... You can either simulate a number between 1 to 100, right? And if it's less than 55, if it's 55 or less, that's heads. And if else, otherwise it's tail. The other way you can simulate it is to produce a random number between 0 and 1. And if it's 0.55 or less, then it's a heads or a tail. So using the random function to do that for you. The next... So, yeah, no problem. So I was going to leave this up to the class. Do you want me to focus on Monte Carlo today? Or sorry, do you first want me to go over Monte Carlo, file reading, or list manipulation? All right. Wow. Everything. File reading. That is a lot. Yeah, I'm going to do both. It was a matter of which one to do first. So why don't we take a informal poll, okay? So stop share. Everybody grab your buzzers, except you don't have buzzers. But you do have, under Manage Participants or Participants for You, a yes or no button. Or so everybody who wants to do Monte Carlo, click check. And everybody who wants to do file reading, hit X. And everybody who wants to do anything else, hit thumbs up. There is a good file reading lecture for reference, but I would do something similar to what we'd see on the exam. Oh wow, it's very evenly divided. Like, super even. All right. All right. I'll give you guys about 30 seconds to figure it out. Yakety sax. All right, so great. You jerks, it's perfectly tied. You people are awful. Okay. All right. It looks like the...
Did they do Benny Hill in the program?
I did. I was doing that while the...
Saying they're awful.
Because I asked them to take a poll and the poll came out tied at the buzzer. Okay, so it looks like that I'll do some Monte Carlo stuff. Okay? So give me 1 second and I'm going to pull up a fun game. And then with the time remaining, I will go over file reading. Okay? By the way, if you have testing accommodations, as one student has already done, please email me and let me know, and I'll do that, and I'll handle that separately. Let the child vote.
Wait, sir, you need to...
Nah, it's fine. Okay, so I actually emailed one of my mentors from my PhD program for something he does during Halloween, which is from the book of How to Cheat at Everything, which he did in his security class. So, let's see.
Don't push Muffy.
All right. So let's go ahead and talk about coin. Let's see. So add 2 red cards. All right. That sounds good. Let's talk about the 9-card hustle. All right. Which I've postulated in the thingy. So which I put in here. So we're gonna have 9 cards. So let's take 9 cards, 7 red and 2 black cards. Okay. 7 reds and 2 black cards. Shuffle and place in a 3x3 array. So a 3x3 square. I'm going to share my screen in a second. I posted the problem definition in chat. I didn't want to share my screen because it has other questions that I've got on it that, but I'll go ahead and share my screen now. And what does it do? Share screen. Okay. All right, so now let's go ahead and code. All right, so let's go ahead and do
That cat doesn't have a
teaching.
probably because you're torturing her. She's letting you though, so I think that's okay.
Not teaching, classroom. That's what we want. ITP, spring 2020. Scam game 1.py. All right, so let's go ahead and put this down here. Here is our thing. View, appearance. Where is word wrap? There we go. All right, so word wrap. Chat. I have no idea why PyCharm is running your old code. Make sure you're selecting to run the correct code. All right, 9-card hustle. So we want to. So from this is a continuation off a previous problem that I might want to use later. So here we're going to add 2 cards, 2 red cards, 7 red, 2 black. We're going to shuffle them and place them in a 3x3 array. Right. So face down. The even money bet I'm going to give you is that your odds are 50-50 that you can find 3 cards in the straight line. So I bet you $5 that you can get that basically that you can find 3 red cards in a straight line. What are you and so if you manage to get 3 in a row, I win $5. You win $5. Otherwise, I get your $5. So we're saying that basically it's a 50-50 shot of you getting this. Right? After all, there's only 2 blacks, right? So, you know, let's think about this for a second. Let's go ahead and draw some configurations. Red, red, red. Black, red, black, red, red, red. So let's talk about this. There's 1, 2, 3. So out of the 1, 2, 3, 4, 5, 6, 7, 8 possible ways of doing this, right? You've got 1, 2, 3, 4, 5 equipped for victory, right? So, you know, that seems like pretty good odds on your favor, right? 5 of the 8 are able to do. You're able to flip and win. So it seems like pretty good odds on your favor. What if we do red and black? Everybody understanding the problem prompt here? 3 red, black, black, black. Black, red, 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 black, black. So we have 1, 2, 3 ways for victory, though, in this configuration. 1, 2. Yeah, 1, 2, 3 ways for victory in this configuration. So that seems less, but hey, we had 3 in the last one, 5 ways winning in the other one. So our odds seem balanced, right? You know? So what we're going to do, though, is because if I'm suggesting this game, you should never trust me if I'm gambling with you, because I don't like losing money. Ever. I'm not a casino. I don't have that kind of leverage, financial leverage. So, yeah. So, first off, what we're going to need to do is we're going to have to work on making a 2D array. So, there's a couple ways we can do this. The first way is we can make just a list like this. and then use modular arithmetic to figure out where everything is in the grid. But that sounds horrible because that is horrible. So for this one, we are going to be using a 2D array, and this will give us or a 2D list, or a list of lists. This will really be giving you a workout here. So first, let's go ahead and generate what we've got here. Right? We've got reds and blacks. Hi! Is that a water squirter?
Nope.
No. Is that a pump?
Uh-huh.
Are you?
A tire pump.
Why are you using a tire pump on my side? All right, so let's go ahead and create our deck. It's equal to 1, 2, 3, 4, 5, 6, 7 reds and 2 blacks, right? So what we got to do is that we got to shuffle this sucker to get our configuration. Import random. So let's go ahead. Actually, yeah, let's go ahead and create this def create deck rather than that way that we'll create a new deck each time we play a game. We'll say our deck of cards is or our deck string is equal to this string over here. Actually, better yet, call it cards. Now we need to shuffle it. Random dot shuffle. Great easy thing to do there. Random dot shuffle cards. Print cards. Actually, what I'm going to do over here is print create deck. Just to test, right? You should always assume that, as my friend who makes quite a lot of money doing software engineering says, always assume you're an idiot, and always check your work. And this is because, and that's true for everybody, by the way, not just you who feel like you're bad at programming. Everybody's terrible at programming, so. Output? Come on. Why am I not? Why is this not running? Yeah, oh, right. Return cards.
When you random shuffle cards, does that do that in place even though it's a string like that?
Yep, it should do.
You don't have to put it back into cards?
Excellent question. We'll see.
Okay.
I'm just not sure why it's not running. Let's quit it and start again. Oh. Hold on a second. I think it's updating. All right. So we'll use that time to look up random shuffle. Python 3.
Okay, I get string object does not support item assignment.
Ah, there we go.
Shuffle.
So it can't shuffle. So it's saying you can't shuffle it because it's immutable.
It's a string, so we got to make it a list.
So we got to turn it into a list of cards. So okay. Cards is equal to list cards. Like that. Boom. And now it shuffles perfectly right. And all's right in the world. Yeah, I just needed to update it. It was like broken because I think I tried to run it while it was updating. Okay. Sorry about that. Cards, list, shuffle our cards. Okay. So now we got to create so we've got our deck of cards. But our deck is going to be a 3x3 array. So what we've got to do is So what we want to do is basically take our list of cards and now put them into a 3x3 grid. So deck is equal to, essentially we're going to be creating a list of 3 things. So a list over here, a list over here, and a list over here. inside a list. 2D. So basically, it's a two-dimensional list. Yep. So now what? So what do we do? Well, let's make a for loop. Okay. For I, or we can just, another way we can do this actually is, let's make it a bit easier to understand. First row is equal to a list of stuff. Why call it first row? Let's be simpler. Row 1, row 2, and row 3. Okay. So for I in range, sorry, for I in, let's just actually keep a counter. So I'm going to do this as basically as not as dumb as possible, as simple as possible. Counter is equal to 0 for card in cards. So for every card, what we're going to do is that we're going to add one to, we're going to go, actually we're going to go ahead and say, hey, let's just go ahead and slice them. So row 1 is going to get the first 3 cards. There's no need to do a weird for loop. Row 1 is equal to cards. So the first 3 cards up to, and so there you go. Then the next 3, then this is equal to card 3 through 6, and then 6 to the end. And return, and now we turn it into a new list. Row 1, row 2, row 3, and now you see that we've got, you want me to get you another shirt? I'm sure Mama will get you one. Row, red, red, black, red, 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 black. So it's a list of lists. Yep. And I'm just going to grab this from Cat. Print grid deck. Laser. Ask Mama to get you a shirt, please.
But now, yeah. So now we just want deck 0, deck 1, deck 2, right? 'Cause
Yep.
now we have 3 rows. Okay, got it. So we got to just change that to 0, 1, 2.
I mean, yeah, we don't need to.
Well, because now we've
yeah.
now the deck has rows, right?
Yeah. So
We don't-
for row in deck,
Yeah, nicer.
print row. There we go. Create deck is our deck. And then print our deck. Or, sorry, print grid deck. This will enable us to visualize what we're getting here. So, right? Looks like we've got it randomly distributed. Okay. So, so the question is, what are the odds of us flipping 3 in a row? Basically. So that is the question we're trying to ask. So first, let's look at the rate. First, we're going to look at because there's 2 different things here. It's kind of a statistical trick. First, there's the total number of, the total number of ways we can win. First, and then there's the total number of number of ways we can win, but we only get to pick one way to win. So, we'll see. But first we got to talk about 2-dimensional array stuff. All right? So deck, right? If I got index 0 of this deck, anybody want to tell me what it's going to give me? If I ask for index 0 of this thing, what is it going to give me? Two parentheses.
Oh, I was gonna say we don't know because it shuffles, right?
Right. The top,
Oh, okay.
the first the first list in the deck.
Right.
What, I missed something?
I thought you meant like what actually was it? And I'm like, I don't know because it shuffled again.
Yeah, it's going to be shuffled, but it'll print out the first row. Index 0 gives, it's a list in a list. So it would give me the first one, right? Whatever that happened to be shuffled at the time, right? In that first example, it was red, red, red. So we can, we can also just first off see the statistics of what's going to happen with that first deck. So count is equal to, let's assume that basically no matter what the shuffling is, I'm going to take the top row. Let's see what the statistics of that are. For count is equal to 0. Count is equal to 0 for let's go with trials equals 100,000 of these suckers, right? For blank in range trials. And now we'll create a new deck each time. And now, deck is equal to create deck. And then if row 1 is equal to deck 0. So we're just going to grab that top row, right? Because it's a list in a list, right? The items are row 1, row 2, row 3. So that's why it gives us 3 items. Because this cuts 3 items, this cuts 3 items, this cuts 3 items. So we're going to get that. And we're going to... There's not going to be any 2D stuff for lists on the exam. Got the same output as Royce. Remember to actually call your functions. Let me go ahead and make it bigger so we can see it all. All right. For deck in range, create deck. If black not in row 1, that means we win. So count plus equals 1. Print print count divide by trials. So let's go ahead and run this. So it looks like if I just look at this, there's a 41% chance of there being a black in this is an exam type question, yes. So it looks like you got a 42% chance of winning, not a 50-50. Let's go. Well, that's only if we're just trying. If every time we shuffle the deck and we take the top row. What if I take the diagonal instead? Well, in that case, we'll need to use two-dimensional addressing here. So let's go ahead and talk about for a second. Comment this out very temporarily, just to talk about 2D arrays, 2D lists for just a second, right? We'll create our deck, just like we did earlier. But now, how do I get the top left corner? Any ideas? This got me the top row. How do I get the top left corner of that? Top left corner of that. And the answer is I got to use 2 of these suckers because it's 2-dimensional. Row, column. So this is 0, 0. So this would be... So let's go ahead and go back to this. So let's check our chances if we choose a diagonal instead. We're going to go ahead and say row 1, we're going to say our choice is equal to the following list. We're going to get row 1, we're going to get the very top left corner. Then we're going to get the middle item. Deck 1, 1, right? Go across a row and then down a column. And then deck, right? Think of this as with matrices, but they start at 0. Okay? Elements in a matrix, but they just start at 0. That's all this is. And all I'm doing is making a vector of them. So let's go ahead. And now if we check the diagonals, it's the same probability. Right? So the chances of me winning the chances of me winning this game are actually closer to 42% than 50-50. So the game is slightly rigged in the favor of the person who proposed the game. Okay. Questions about this one? This is way harder because than I'd put on the exam because it required a 2D array. Do people want me to do another one? Okay. Let's do one that might be slightly easier, I feel. Definitely easier. Definitely of the difficulty that would be on the exam. Okay. So, let me go to and generate another one. And I'm going to just grab it because okay, I'm going to create another one. Scam game 2.py. Okay, this one's another. Do you have an example that breaks it down the way an exam break it down? Just the one from Monopoly and the other one I did, but I'll come up with this one on the fly. Okay. Yep. Okay. Here's one that I would give on, that I think would be of good difficulty to give on an exam. Okay. Coin flipping, Bernoulli style. Let's assume that basically a coin is an even odd flip. The odds of flipping a coin fairly and getting heads or tail is 1 or 1, right? Everybody agree with that? That's not the scammy part, okay? We can take this for granted that a coin flip is 50-50. And I will post this in the chat for anybody who needs it. Oh, sorry. That should have gone to everybody, but apparently I sent it to one person because... Oh, weird. Coin flipping. So, odds of getting heads or tails is 50-50. So, you might say, if I'm like saying, here, I'm going to give you an even money bet that you can get 5 heads and 5 tails in 10 flips. So, what is the real odds of getting... 5 5 heads and 5 tails, right? So I come to you, I'm saying, hey, I bet you $5 that you can't, so we're going to play a game. If you can flip 5 heads and 5 tails, then in any order, 5 heads and 5 tails in any order, then I'll give you $5. But if you can't, you give me $5. So, or perhaps like a tenth of a Bitcoin or something like that. They really dropped in price. Okay. So glad I got out when I did. So, let's go ahead and see. What are the real odds? So this is actually what we call a Bernoulli trial, which is why it's called Bernoulli style. Name of mathematician. But basically, this kind of thing is... It seems kind of intuitive, but it's not really once you understand the statistics behind it. So let's go ahead and break down. Let's go ahead and see what, if this was a 20-point problem, let's go ahead and see what I would want to do. Let's see, 5 points. I'd say maybe 5 points to do, let's go with, let's see. Yeah. Let's go with 5 points to generate. Let's go ahead and do. Let's go ahead and get the what I want up there, and I'm just going to list them at 5 points, then I'll modify. Generate a coin flip. 5 points to generate a sequence of 10 coin flips. 5 points to simulate Probably something more along the lines of this. I'd probably give the distribution of points somewhere closer to this, or possibly 3 and 7, 7, 3. But it would be broken down into those 4 tasks. Does it make sense to everybody? Does that seem nice and clear to everybody? Okay. So first thing we'll need is that we can import random. And if you forget to import random on the exam, you are hereby expelled. Actually, no, I just won't care. Well, if it was on paper. But I'm going to assume that you're going to do this in idle or something. So remember to import random. Okay? You'll want to use it. Okay? So, the first thing is to generate a coin flip. Let's go ahead and just simply let's just go ahead and write a stupid function to do that. Coin flip. Or, yep, we'll call it coin flip, whatever. Or you can call it flip coin, it doesn't matter. And we're going to return a random number between 1 and 2. And we can either simulate this as, honestly, we can do this as tails or heads and tails. So I'm just going to use heads and tails because why not? Random dot rand int is equal to, gives us 1 or 2, right? So we're going to generate randomly between 1 and 2, okay? The flip is equal to, so we're going to say if that is equal to 1, return a head, else return tails. Okay? There we go. So we're just flipping a single coin and asking, hey, so let's go ahead and basically generate, so the next task, that's 2 points there, generate a sequence of 10 coin flips. So we can either do this as a list or a string. Either one would be correct. It just needs to be a sequence. Basically just some kind, we have to have some way of collecting our results. It could be a list, it could be a string, whatever. It doesn't really matter to me. But you just need to have some way of basically figuring out how many are in there. So you need a collection. So generate 10 flips. For blank in range 10. So we need to generate coin flips. Results is equal to, let's go ahead and make this we'll go ahead and make this a string. People want me to do this as a string or a list. Any opinions? List. First, all right, so we'll go ahead and do this. So results. So coin flip. So we'll do results dot append coin flip. That's all we need. So we'll flip the coin and we'll add the result of head or tail onto there. So coin, or we can just simply do flip is equal to coin flip. A lot of people like to break it down into the statements. That's perfectly fine. Return our results. And now and then I'm going to show for, okay. And then simulate a game of, yeah, I would definitely change the weights of this so that this would be 5 and 5 because the simulating the odds is a bit trickier. Okay, so generate 10 coin flip. So let's just go ahead and test it, right? You should always test your code. Print. Always print. Remember to execute it with our parentheses. Tail, tail, head, head, head. Tail, head, head, tail, tail. Okay. Tail, tail, head, head, head. Tail, head, head, tail, tail. That's perfectly fine. And then we can generate, let's just make sure we run it and get a different one. And we'll get a different one, and there. Okay, so next, let's go ahead and simulate 10,000 of these suckers. You can do this in a function, or you can do it outside like I'm doing it. It doesn't really matter. trials. Let's do how many? 100,000? 10 coin flips. So let's go ahead and do that. So first, before we try to figure out, start counting it, let's just simulate 100,000 of these guys, right? What we would need to do is 4 blank in range trials, and then just simply generate 10 flips. Game is equal to generate 10 flips. That's it for 5 points. Why do I use a blank instead of a
divided by
variable?
10. How many are we trying to do?
100,000.
Oh, okay.
So that's the easiest 10 points you'll make, or 5 points you'll make there. So when I use a blank there, we use blank when I don't care about the variable. That's why I use it. You could just do I, but we're never going to use I, so it doesn't matter. It's not a right or wrong thing. It's just a stylistic thing.
So we only want 10,000 since we have 10 per trial? Right?
Well, no, 100,000 games of 10 coin flips.
Oh, okay, of 10. Got it, sorry.
Yeah, it's fine. If you misinterpret that, I'm not going to really take it off or anything, because that's not the core of the problem, right? The core of the problem is, do you know how to do an experiment? And so now we need to basically see def is winner. Let's make a function to basically figure out did I win or not. So here's my coin flips. Is this a winning thing? I need to figure... So there's a bunch of different ways to do this, all of which are very clever. So the first thing I can do is just simply count the number of heads that I have. For flip in flips, right? For every coin flip, or let's go ahead and do this. For coin in flips, if coin equals heads plus equals 1. And we want 5 heads or 5 tails. So if we get 5 heads and it's 10, then we know that there's going to be 5 tails, so we don't have to bother countering the tails. You could also as easily count the tails instead, but you only need to count one of them. And then we can say, hey, return heads equals 5. So if there's 5 heads, it'll be true. If there's not 5 heads, it'll be false. Okay? Another way to do this, which is also short but particularly silly, I find, is that you might remember the whole sorted method we used earlier. So you might say, hey, flips is equal to sorted flips. So now remember, sorted creates a new list that's with the results being sorted. Now, when you sort strings, they go in alphabetical order. So basically, we should be getting head. So basically, if we had 5 heads and 5 tails, it would be 5 heads then followed by 5 tails. When we sort it. So that would sort it and put it into order, and then we can say return flips, the first 5 things in flips, if that's equal to head, or actually we can ask we need to do if the first is equal to heads. I was trying to be clever, but then I realized my cleverness was a mistake. So we can sort it, and then that. What's the difference between sorted lists and sorted list keys? The latter is only for the dictionaries. That sorts the keys. That creates a list of sorted of all the keys that are now sorted, so that they're in order and you can easily print them out instead. I'll do that in a second. Sorted lists just takes a list. The difference between lists and dictionaries is that dictionaries have keys and value pairs, and lists just have the values at a certain index. So we'll do that when we do a more thorough analysis of this. Did I initialize flips? It's a parameter, so I don't need to. It will be passed in somewhere. So let's go ahead now I'm going to go ahead and check this first method instead. I'm going to go with this first method because I know it's bulletproof. So let's figure out what our statistics are. If is winner game count plus equals 1, and I did not initialize count, so count is equal to 0. What does return heads equals 5 do? If this count of heads is equal to 5, it will be true. If it's not equal to 5, it will be false. Now print trials divided by, counts divided by trials. Not counts, it's called count. So my chances of winning this game are not as advertised. It looks like I only have a 24.75%, it looks like. Close to a 25% chance of winning. Not 50. Now, why is this? Because, well, let's go ahead and instead analyze our results a bit more in more detail. Right? This is all you need for all 20 points, by the way. But notice that each of those individual problems were pretty easy to do. So, let's go ahead and just analyze the results to explain this answer. The real odds of me winning are 25%, and the reason is because it's a bell curve distribution. Would I grade something like this by hand? What do you mean? I mean, I would ask this question, and then I give you an entire page to give me the answer. But I would grade it by hand generally. I would grade you doing it by hand. Oh no, I'll have to grade these suckers. It's unfortunate. We're gonna have to manually grade all these. It's gonna be terrible. Yeah, I could, but honestly, that might not be the best thing. Yeah, partial credit would suffer if we were just going pass fail. No, I think what I'm gonna do is I'm gonna tell your TAs to grade it, and I'm gonna have a specific rubric for each question. You'll be able to see the whole test at once. Okay, so let's go ahead and figure out why this is the case. So rather than checking if the user's the game, let's go and keep track of the. Let's create a dictionary, a table of wins and losses. So what we're going to do is we are going to generate our game like we did earlier. Well, the good news is that there's going to be very few questions on the exam, and it will only be 30 people per section. So sorted game. So we're going to sort this. Game is equal to sorted game. And then what we're going to do is we are going to add this to, we're going to say, hey, have we seen, this is going to be a certain result. And if game in table. So if we've seen this result, we're going to say table, let's call it result instead over here. If this result is in the table, table.result, no why. Table.result plus equals 1. Otherwise is the first time we've seen this result. Table result equals 1. Run it. Unhashable type. Ooh. Can I scroll up for a second? Yeah. Unhashable type. So that it means that basically I cannot use a list as a it means unfortunately I can't use a list as the key to a dictionary. So in that case I got to use a string. So if result in table, in that case I'm going to go ahead and say for in that case, I'm just going to turn it into a string. I am a dirty cheater. And now, for result in list, sorted table dot keys, right, which will give me all the keys. So this gives me all the keys, but in no particular order, and then I sort them so now that they're going to be in alphabetical order. Print result and results, and then we get the associated count with it. Table result divided by trials. This would be above and beyond anything I ask you in the exam. So let's go ahead and see what our beautiful results are. So as we see before, 5 heads and 5 tails have a 25% chance of occurring. But as you can see, it's kind of like it's got this bell curve shape to it, essentially. You've got basically 25% chance of evens, but then a 20% chance either way for a 6-4 split. Right? 6 heads or 4 tails. And then 11% chances over here, and so on and so forth. So that's why because this is all the different possibilities you have when you flip 10 coins. Right? Just because it's a half a chance of getting 1 doesn't mean it's a half a chance of getting for 10 of them. So this question is much more like, this, except for the whole thing where I used the table over there, is definitely way more of the type that I would give you on the exam. This question, I wouldn't ask you for the frequency table. I just ask for you for your chances of winning, not necessarily for what the things are. And a good way to know is that I generally your chances of winning these games are going to be very low because I want to win these games. Okay. So let's go ahead and generate a bunch of random numbers, shall we? Let's go ahead and look at this So let's go ahead and talk about let's do file reading for a second, actually. Let's go ahead and let's see. We've got time temp. So let's go ahead and create a CSV table. Hold on a second. I'm gonna actually see if there's CSV. Alright. Of course there is. Thank you. Download. Cancel. Raw. Thank you. Copy, paste. Copy. Paste. Pokemon.csv. Alright. So, if you haven't played Pokemon before, I am sorry. Will this be uploaded to GitHub? Yes. Pass-fail situation? Dunno. Would we have to download the exam as a PDF? It will be right on Canvas. The questions will be on Canvas. It's going to be like a jumbo quiz. All right. Okay, so here we have Pokemon.csv. It is a CSV for all the Pokemon. Well, let's see if it's for all the Pokemon. It's for all the Pokemon, I guess, except for the latest generation. So everything before Dexit, I guess. So whatever, it still works for the things. Now, Pokemon is a very competitive game. It's a when you do that. I will be doing a full review of the practice exam on Tuesday. This is just an example problem. So let's take a look at this CSV file. Okay, Pokemon apparently have a number. So Bulbasaur is number 1, although I disagree with that statement. Name, type 1 and type 2, and then we've got numbers, total, and total is the total of its HP, its attack, defense, special defense, and speed all added together. So, how dare I? No, it is Squirtle Gang. Thank you very much. Although, honestly, Game Freak seems to really, really love their fire types for some reason. Anyway, let's continue before this devolves into an overall brawl fest. So what we want to do is let's figure out what the average attack stat of all Pokemon are. So all Pokemon have number, name, type 1, type 2, total, attack. So if I were to ask you, on the exam, I might give you a question like, here's a file containing all the Pokemon. And it's formatted like this, except I'd format it a bit easier to read. So let's go ahead and just simply I'll simply mark this. I'm going to copy this bit over here. So we've got field 0, 1, 2, 3, 4, 5, 6. So I might ask for, give me the average class. Where do you find this? I literally typed for Pokemon.csv. Alright, so let's go ahead and write a file that basically will do some calculations on this. Pokemon.py. Okay, so let's first open up the file. File is equal to, or let's go with data is equal to open Pokemon.csv. Remember to make sure it's in the same folder. I'm going to put it in read format. Okay, now what we need to do is read it file by file. Okay, so read it line by line. So for line in data. Let's first print it out to make sure that we're reading it correctly. Don't print out data, print out line instead. And we are printing out and we have successfully printed that out, as you can see here. So now let's go ahead and modify that line. It's a CSV file, so let's change it up to see how much. Let's go ahead and split it up into its general field. Heracross is pretty good. My personal favorite Pokemon are Gallade and Gyarados. So, line.split. Deathfish for the win. Okay, line is equal to line.split, print line. Now, when we do that, so now we've got it split up into when we don't want to split it up by that, we want to split it up by commas, because it's a comma separated value file. Because otherwise we're not going to have enough. So there. You'll just need to download it. I'm going to upload it in as part of the GitHub though. So here we go. I was looking for something interesting to download, and I didn't even download it. I just literally created a new file and copy pasted this data into there. So there we go. we've got 1, 2, so we've got 0, 1, 2, 3, 4, 5, 6. So field 6 is what we want, which is attack. So we want to find the average attack of all Pokemon. So first off, let's go ahead and say, first thing we need to do is make sure we don't get this file, but I'm not going to give you like, oh, remember to sanitize the first line. How do I show it? How did I get it from GitHub? It's very... Here's what I did. I typed Pokemon.csv. I went, oh, that looks promising. Oh, it's a table. Hit raw. Control A, Control C. Control, and then I pasted it into here. It was a very quick and dirty way to do it. All right, so we've got the line. So now let's go ahead and get the attack from every line. So, total lines is equal to 0. So that's going to be the number of lines we read. Total attack is the total attack of all Pokemon combined. So what we're going to do is that we split this line up. We say attack is equal to int, and it's item 6 in this. So line.
I reorganized my desktop screen during this class because I was bored.
I'm sorry you were bored.
I mean, I can, but I don't want to do that. But I reorganized everything on my desktop screen.
Right.
And I don't know if I like it.
Well, I'm going to go ahead and...
I think somebody's talking who doesn't realize they're talking. I'm not sure. They're just saying.
I'm going to go ahead and mute it. Give me 1 second. Participants. Mute all. Alright. So. It's okay. Line is split. Attack is equal to line 5. So we've got that. So now let's go ahead and say total attack is equal to... Look, if you don't want to be here, I'm not keeping you here. You're adults. Well, most of you are... I think you're adults. Like 18 and above. So, you know. Attack, lines. High laser. You see... I've got a toddler. It's not really easy to troll me. So, high laser. Are you mixing Legos together?
No.
That's what you do. 4 line in split. So here we've got our attack, our total line. So let's go ahead and print out those results. Total attack, total lines. So we've read 800 lines. Oh yeah, because there's mega evolutions. That's why, even though it says 721. See how many lines we got? 800. And then we got our total attack. So now we want to print out the average, which would be total attack divided by total lines. $79 is equal to 0.001. There we go. So the average attack is 79. So it is 317, and that sounds like a good stopping place. So here's the plan. Let's see. Someone just really? Yeah, that's below overused. Well, we're talking about average. Remember, Magikarp and Shuckle are in there. I mean, they'll drag the things down right by themselves. Alright, so I think that's a great place to stop. So I'm probably not going to do any videos over the weekend. because just I want to give you plenty of time to prep for this. So be sure to go over these lectures in prep for the next. No. I'm not a sadist. I'm not going to do it with Magikarp. I will gladly do a Nuzlocke run. I will do a Nuzlocke run at some point. But, I guess Royce, you want me to battle you on, Sun... I've got Sword Shield, so I could ostensibly get that. Can I give you the prior Zoom link? Yeah, I don't have I don't have the stuff to stream Pokemon on Twitch, I don't think. Whatever, this is getting off topic. Let me go ahead and get back on topic. Exam next Tuesday. What we're going to do is we are going to go over the practice exam on... Sorry, not next Tuesday. Next Thursday. I will be posting this video basically ASAP. Okay, so I'm going to post this video ASAP. Tuesday, practice exam, we are going over. I'm going to go over top to bottom. Then on Thursday will be your exam. If you can't make it to the exam, please let me try your best to let me know prior to the exam starting. I'll try to make the exam short, with basically made up of problems that have a discrete rubric built in, so you know if you do this, I'm going to get this much. Do you need to keep your microphone on during your exam? Not necessarily. Yes, you can email me and Kat for help. You do not need to keep your microphone on, but please keep a webcam because that will help me see that you're not talking to another person. I don't want to... I mean, I'm just going to proctor you as best I can. Please, I would like you to keep on the exam. April 2nd is the exam. What if you're talking to yourselves? That's... perfect. That's why I want to keep it muted, because there's probably going to be at least one of you who have, like, your little brother barge in when you don't need it. Yes. You can mute the volume. I just want to see your faces, to see that you are not talking to anybody. Headphones are fine. Yeah. Yes, we should be transferring a code with indentation. So I'll try my best to make sure that you can do that. Worst case scenario, I will let you attach a file for every submission. Okay? So I'll see the best I can. I'm going to work on that this weekend. So I'll write the exam on Canvas this weekend. I'll try taking it doing a couple of my questions myself so I see how it works. Worst case scenario, I'll teach you how to use the HTML there, which is not that hard. You just simply do it's something along the lines of like and then there's something other then there's something else that you put, some other block you put, and then whatever you paste into there will be properly indented. When in doubt, use the... So yeah. All right, sure. I'll be happy to battle you at some point. So let me yeah. All right. So just send me an email or something. Anyway, that is it for today's class. I'm going to go ahead and upload this. All right. All right, stop share. For those, and somebody asked about me being here. Yeah, I've got a couple minutes. There's no reason why. I'm in no rush. So if you need some help on something, I can go over that with you. Let me just... Yep. So go ahead and I'm going to let everybody file out as they need it. If you need to stay behind, you can. But right now the first thing I'm going to do is upload the lecture. So apparently, Annie, people have been joining the Zoom lectures and trolling. Like, somebody had another professor who got cursed at. So the
Like strangers, right?
yeah, apparently.
I've seen some people join public Zoom.
Oh, I'm not